Hello, everyone. Thank you for tuning into the Software Plaza podcast. I'm Twain Taylor, editor at Software Plaza, bringing you some of the latest and greatest in the space of cloud native computing and Kubernetes. And if you like what you hear in this conversation, definitely head over to multiple places that you can find us on YouTube. You can find us on our website. You can find us on Spotify and the other podcast platforms. So wherever it is you want to listen or watch, we're there. So definitely subscribe and stay tuned to these conversations. We've been doing them for a while, and we're quite stoked about just the quality of conversations that we have with builders, with founders, with organizations large and small. Today I have with me Sebastian Scheele, who is the CEO at Kubermatic. That's Kubermatic. They're an organization in the managed Kubernetes and the Kubernetes platform space. And Sebastian is here to tell us all about their approach and their views and their perspective on where how things are shaping up in this space. So quite excited to be talking to Sebastian. Sebastian, thanks for joining us. It's great to have you on the podcast. How you been?
Yeah, good. Thanks for inviting me. Really looking forward for the conversation.
All right. Yeah, I was just thinking back about how I came across Kubermatic probably in 2016 is when you guys started. And that's really, really early when you talk about the Kubernetes world. It was just pretty much like almost, uh, as soon after Kubernetes itself launched, uh, that was when you guys started up your company and your team. So really early. So you guys have been around. You've kind of seen the genesis and the evolution of Kubernetes. You guys have been around for a while. Tell me a bit about. Actually, before we get into that, just tell us a bit about yourself and just your journey leading up to Kubermatic, and then we'll get into the start of Kubermatic.
Yeah, absolutely. I mean, I studied computer science, so I have a technology background, and um, then I started my career at SAP, first in the consulting. I mean, compared to Kubernetes and containers, I did something completely different, like implemented ERP and CRM systems, so more on
Yep.
the process and side. And later, when SAP announced the new database HANA, I moved into the in that area, was working there in the product management there, and because yeah, it was a new big topic inside of SAP, and but then I was looking a bit of the outside world, and yeah, things like Node.js were coming up. Then Docker was coming up, and I said, okay, after I think 7 years or so at SAP, potentially I really want to work with all these nice open source tools, and decided to leave. And yeah, was regular cycling with my co-founder Julian, and so he also told me, "Hey, I'm leaving my job," and I said, "Yeah, if you ever want to do something together, potentially now it's the best time to do something." And I said, "I know there's some interesting open source projects. One is called Docker, and the other one is Kubernetes." And so we said, "Okay, yeah, let's do something with it. Could be interesting." And that's a bit of the background where everything started. And yeah, so we really like from I think I started using Docker like Docker 0.5 or so, and why I get yeah in touch with Kubernetes were like we were developing some stuff, and the challenge was every time like how do we deploy this, how do we manage this, and should we use tools like Ansible or so, or how do we deploy this to multiple servers and so on. And then Kubernetes come out, and it was like, oh yeah, interesting, that could be an interesting way to solving this. And so this is how I came in contact with Kubernetes, and like really there from quite the early beginning.
Wow. Yeah, those are the times. I remember, it was all about Docker Swarm versus Kubernetes in 2015. and kind of polarizing, just people taking sides. And then it was quickly settled, okay, Kubernetes is the way. Tell us a bit about just that phase and just the founding of Kubermatic.
Yeah, absolutely. I mean, I think this was a big battle at the beginning. Like, should we use Docker Swarm, Kubernetes, or Mesos? And so I remember, I think with some other guys, we even had a talk on a conference where we were comparing all the three tools. Showing like, oh, okay, what are the benefits and downside of each tool? I think more or less it was settled that Kubernetes is a winner was when really AWS announced, okay, they will provide an managed offering of Kubernetes, and I think then more and more like clearly said, okay, it goes. We will follow more the Kubernetes path, and but it was definitely really interesting at time, and also like see the whole ecosystem, CNCF growing at that time. I mean, now I'm also on the CNCF governing board, like representing the silver members. Helping like also to create a voice for smaller companies in the CNCF and like see like how this grows from a few projects from a few companies who were there in the beginning. I think nowadays we have 600, 700 members in CNCF, and I don't know how many projects there. So it's really interesting how the whole ecosystem exploded.
Yeah,
And
yeah,
I think if you would ask the people at the beginning, I think even in their dreams, nobody would expect that to get so quick, so big. So it was really an interesting journey.
yeah, yeah. Wow. And yeah, quite interesting. It was really like a trip down memory lane to hear you, tell us some of those, situations that we had back then, about a decade from now, a decade earlier. Yeah, so I wanted to ask about, so Kubernetes itself has evolved as a product, as a platform. The space, cloud native computing has evolved. And along with it, startups like Kubermatic have had to as well evolve. Could you trace some of the major changes from then to now? What were some of the early issues that people were grappling with, and how has that changed to now? Are we dealing with different kind of problems today, 10 years down the line? Could you kind of trace the history for us, bringing us to today?
I mean, I think at the beginning, the biggest challenge was just get a Kubernetes cluster up and running. I'm the only managed cloud provider at the beginning was GKE and on Google Cloud, but no other provider really had a managed offering. And if you were not on the on the cloud providers, it got even more difficult because there was even no tooling around this. So you needed to build up uh, stuff on your own. I mean, there was even not kubeadm or so there were some bash scripts available to set up and deploy the whole control plane of Kubernetes. And I think that was definitely in the early beginnings one of the biggest challenge, like how do I set up a Kubernetes cluster? This evolved over time. That setting up a Kubernetes cluster itself gets more easier. But day two operation, I think, was and is still challenging. But also, I mean, nowadays, not just Kubernetes is enough. I mean, we see the whole ecosystem. For example, for just getting a plain Kubernetes cluster running, you need to think about networking, you need to think about storage. So you already have two components you need to think about. And then if you want to bring stuff into production, especially for enterprises, a lot of more stuff comes into the picture, like how do I manage policies, how do I manage security, and so on and so on and so on. And yeah, it's nowadays not only like, oh yeah, just here's Kubernetes, check mark done, ready. It's more really about like what else do I need? And I think what a lot of companies also underestimated is like how big the change in the organization is, because it's a complete different mindset. It's not only, okay, here's a new tool. On the one side, it's about changing the processes, like going more to a GitOps based approach, but also building up the knowledge in-house in the organization to really leveraging this technology on the one side, for the platform team or for the team who's operating the cluster, but also for all the developers that they can build applications for Kubernetes.
Yeah, yeah. So different problems, you know. And what would you say are some of the solutions that have come up to some of these problems that we're facing today that you had just mentioned, the day two challenges, networking, storage, all of these other challenges that we face today. Uh, what would you say are some of the solutions?
I mean, first of all, solutions which are part of the CNCF, for example, of course, Kubernetes itself as orchestration engine, but then tools, for example, policy management like Kyverno or OPA for policy management. Um, Storage is every time interesting. I mean, there are commercial ones, Portworx, NetApp, for example. I think it's interesting that there on the open source side, there are only a few, which is somehow surprising. I mean, the good old one, Ceph is still there and used, but then it gets already like smaller and smaller. And nowadays, as more stateful workload is there, it's interesting that there's not so much open source storage out there. In a lot of cases, you have a quite big competition on open source tools versus a commercial one. And then commercial distributions like we do with Kubermatic, who packaging all the stuff together so that for enterprise customers, like you don't need to figure out, okay, what components of the CNCF landscape I need to put together, but especially I think what's completely different versus in the pre-container phases like the release cycles. I mean, Kubernetes follows a 4 month release cycle, and a lot of other components are also on a really tight schedule. And I think this was before, if you like 10 years ago would tell an enterprise company, hey, your major infrastructure platform will release every 4 months new stuff you need to upgrade and so on. And as max, they provide you support for roughly a year. I would say everyone would tell you, no, that's not possible at all for our organization. We need at least 4 or 5 years support of a specific version. But I think a lot of enterprises adapted this, and I think this helps also, to keep the speed on releases and so on.
Yeah, and I think it kind of also echoes, you know, what happened with just when containers were, introduced. It was about kind of standardizing, you know, packaging different libraries, so that, you know, you have consistency and that enables just faster deployments, more consistency. It's more collaborative, and you can share packages, collaborate around them. I think that in a sense, we're kind of doing that now at a more abstracted level where we are talking about how to standardize and package services, cloud services. Would you say there's a parallel there?
Absolutely. I mean, I can remember at the beginning of the whole cloud native, there were huge debates on what container runtime people are using. I think nowadays I never hear from a customer asking explicitly, okay, what container runtime are you using, even if there are multiples. It's a detailed implementation detail. Rarely someone care. At the beginning, everyone was like, "Oh, are you using this or that or what you're using there?" And I think now the stack goes more up and up, and people understand some stuff of this gets more and more commodity. It's like same with the Linux kernel. I mean, also not every bit detail will be questioned and asked every time. Of course, there are cases where you say, okay, the one is better versus the other, but for 80-90% of the use case, it doesn't matter. The one what is there is good enough or is performing as expected, and you don't need to like look on this thing on the last bits and bytes to improve there. So you're moving up more and more the stack, and the underlying stack gets more and more commodity. And exactly as I said, like now we are on a different abstraction layer. which also I think is required, because one of the biggest challenge in enterprise IT, I still see like the big criticism that people are saying Kubernetes is complex. Yes and no. In some kind, I agree. Some kind, I disagree. But uh, if I'm writing a business application, and do I need to know like how networking and all the stuff works in detail? I mean, if I write a business application, I already need to be an expert in this business logic, potentially even understand the law and be compliant to the law, and so on and so on. That's one challenge on the one side, and now I need to be even a network and storage expert. So I think it needs to be abstraction layer, because otherwise there is not one person who can really understand all the complexity at once. We every time will have specialized teams, specialized people.
Yeah, yeah. So yeah, so there's, you put that well about how just, uh, with Kubernetes, there's different problems we're solving. And I want to ask about just AI workloads, which is kind of new on the scene where, there's definitely a lot of interest in AI. And so, how does that change things for someone who's managing a Kubernetes stack in an organization that now wants to move to more AI-based workloads? What's changing for them?
I mean, I think one of the biggest changes is, first of all, in a lot of cases, you need GPU support inside of the container. Also, compared to a classical microservice application, the operation pattern or the application pattern is different. So potentially you have huge network traffic, or you need to have huge memory, and so on and so on. So I mean, in general, you need an orchestration engine. And if you look into like how most of the AI tools are built and how they run, they are built based on containers and on Kubernetes. But there needs to be still some work to make Kubernetes more built for this kind of application, because yeah, it has a different pattern, and to support this kind of workload, and make it really, really like best use case for this. But I think it's better to improve Kubernetes on that side, instead of coming up with the next orchestration layer who's only purpose built for the AI workload, because then you later have similar challenges what we had before the container and Kubernetes was standardizing stuff. You have fragmentation again, and then the AI workload goes the one way, the normal workload goes the other way. You need to have different operational teams, and so on and so on. And it gets more expensive to operate this. And I think let's better fix this in Kubernetes, and still getting one tool stack which can support both. Yeah, that's from the workload perspective. From our side, that's one different use case. We heavily looking into it. The other use case is definitely how can AI help to make an abstraction layer on top of Kubernetes, so that not everyone needs to be an expert in Kubernetes just to get some information out there. I mean, with tools like MCP and so on, why you let's connect this to an LLM, and you can just say, hey, how many servers I'm running, what's the status of my service, so that then it's easier to collect this data without knowing, okay, I need to do kubectl get service also to get this information, and then I still need to interpretate this, and so on and so on. So there's also another angle which is interesting for Kubernetes, like how can AI can be leveraged to make make the life easier for developers who are not so much a deep expert into Kubernetes, but still need or want to deploy to Kubernetes.
All right, I'd like to, get into talking about just, what this means also in terms of the developer experience and how that's changing. And certainly we've heard about the platform approach. So if you can kind of tie the threads we've been talking about so far, and how the platform approach applies to all of this. That would really help.
Yeah, I mean, at the beginning, the main term how everyone want to be called was SAE. I think nowadays it's called platform engineer. But I think the main idea is quite similar. Like, okay, you have dedicated expert teams who knows how to operate specific services. For example, for Kubernetes, like container as a service, and provide this inside the organization to other teams, and so they can really consume their service. Like, and I think then it's also not a big difference if you're just working if you are an internal service provider and providing stuff inside an organization, or if your customers are external. I think the biggest difference is just if and how the money flows. If you're internally as Max, you do internal cost allocation in most cases. If you're doing this with external customers, you really get money transferred. But from a mindset wise, I think it's quite similar, because in both cases you really want to come up from a more product based approach, so that you really design a product and providing this product to your customers. And I think that's one of the main ideas behind platform engineering, so that you really build up services and products for your developers, what they can consume, but where you can also abstract stuff for them, so that it's as easy as possible for them to consume, and they don't need to be an expert from A to B. I mean, the best thing is like, hey, you want to create a new I don't know, microservice. So first of all, you need to have a new Git repository. Then you want to include this automatically in the pipeline. Potentially, in the first step, you need to have a development cluster, so you can generate this automatically. You want to have monitoring attached to this directly, and so on the one side, you can pre-bake this for the developers, but also you can really define standards, so that not each team designs it on their own, because if you're running more and more teams, this is not a scalable way. You really want to have for common services some standardization, and I think there really this platform idea comes into the picture to really provide this kind of services and standardization to your teams.
All right, so you broadly defined this platform approach for us. But when it comes to Kubermatic itself, is there an approach that you take to platform engineering that kind of is your perspective and your take on platform engineering? And would you like to share some of that?
Yeah, absolutely. I mean, some is a bit about our lessons learned as well. So when we started with Kubernetes, we had the initial idea from the beginning on like, okay, we think in the future you need to run a lot of Kubernetes cluster. And so we built a platform with a Kubernetes platform to run tens, hundreds, or thousands of clusters at scale. And what we used there, like we were prototyping, like, okay, what's the best way how to manage and operate Kubernetes? And so at that time, like operators and so on were not a thing. So we came up with the idea, can't we use Kubernetes to manage Kubernetes? So technically what we built at that time already, even that CIDs and a lot of stuff were not existing, was a Kubernetes operator who knows how to operate Kubernetes on Kubernetes, and also who knows how to create VMs or provision worker nodes on the provider itself. And so we also had from the first day on this idea, like, because our first customers at that time were service provider who provide managed Kubernetes to external customer, because they had from the first day on this problem. I cannot just create one big cluster and share this with multiple clients. So each client needs to get its own cluster. I need to have something compatible what the hyperscalers are building, so that they can provide individual clusters. And so we had also from the first day on this mindset, okay, we want to provide a self-service, so that our customers, doesn't matter if it's service providers or internal customers, can provide the self-service to the developers, and they can spin up clusters on their own. They can manage the whole day two operation on their own. And one of the lessons what we learned with this, because then these customers were coming like, okay, your approach is working really well. We want to do more stuff or want to provide more stuff as a service, like database as a service or yeah, application as a service. And one of the things what we saw and learned is like, okay, the fundamental part for this is like somehow you need to you need to have an API, a flexible API, how you can expose the service to the customer, because like the big hyperscalers have this. They have their, like AWS has their own API, Google and Azure as well. And they are, for them, it's easy to add a new service. I mean, I don't know how many services AWS nowadays have.
Mhm.
So if they add a new service, they add it. And as a consumer, it makes not a big difference if I'm now using EC2 or EKS instance. The API itself, I mean, of course, the objects and the details, it's a bit different, but in general, the API itself behave quite similar. And so we were also thinking about, okay, we somehow need to have this API, and especially we need an ecosystem how this API can be consumed, because yes, we can create our own API, but then no CI system. We need to can consume it out of the box. We need to build and maintain Terraform provider or cross-plane provider and so on and so on. This creates a lot of efforts, and so we came up with the idea. Wait a bit, there is an API which is quite extendable and quite scalable. Can we not use the Kubernetes API as a generic API? Because if you removing deployments, pods, and so on, and just having CRDs, it's a generic enterprise infrastructure API, which follows the control plane pattern to use this. And so we jumped on a project was initially started by Red Hat called KCP, Kubernetes-like control planes, which is now a CNCF project, where the idea is like, hey, we need to run a lot of Kubernetes clusters, or not Kubernetes cluster, Kubernetes API servers at scale, just to have the control plane. We are not care so much about the container in this use case, because think about crossplane. With crossplane, yes, it runs on Kubernetes, but what it is managing, it don't need to run on Kubernetes. It can manage resources on AWS or other services. And so I think the fundamental part well, one of the fundamental part is the API, and also there is this manifest from Jeff Bezos where he said, okay, in the future, all teams can only communicate over APIs and services, and only with this, AWS got really successful. And so our idea on the developer platform is like, hey, we need to have a common API layer, and let's use as a common API layer the Kubernetes API, so that you can build higher level services on top, that you can provide any kind of stuff as a service. So on the one side, you have the platform team who provides a general platform. And then you have dedicated service teams who are the expert in the service. Is it, for example, it can be development tools like providing Git repository, CI chain, cloud accounts, but it can be also other services like the database team is providing database as a service, or you provide network as a service, depending on what you have in your organization. And typically in an enterprise organization, you have already the specialized teams, but in the past, they don't really have this API to expose this and to make this accessible. In most cases, they had a ticketing system and you can request it over ticket. And I think this needs to be fundamentally changed.
Oh, interesting approach, the Kubernetes API to manage. It's kind of like this Kubernetes tagline, which I was reading some time back, which they had a platform for building platforms. That's pretty much what you guys have done.
Exactly. I mean, that's exactly the idea. Like, it can be then a platform for building a platform, and also with this criticism, Kubernetes is complex. I mean, at the end, Kubernetes is a REST API. If you would build another API on this, in most cases, it would be also a REST or some kind of API. So you need to learn it anyway. I think the complex part really comes into, for example, if you're looking into a database operator, it's quite complex. I fully agree. But is this database operator really built for a developer? No, it's more built for the team who's operating the database, because they want to have all these kinds of capabilities, like I know all can manage all the stuff. I need to manage this at scale. But for the individual developers, you potentially just want to have a simplified object where you can say, hey, my database just has 2 parameter or 3 parameter. I can define the kind, it's Postgres or MySQL or whatever. I can define t-shirt sizes, small, medium, large, and I can define a version. But in most cases, potentially this is even enough. So the object, what the developer really needs to work with and see, can be really small and minified, versus then in the back end, you can, based on this information, you can map it and generate the real object what you need. That, for example, if you just say t-shirt size small means 2 vCPUs and 2 GB of memory and storage type SSD or whatever. And but this is implementation detail what the developer don't need to know, don't need to see, because he should be responsible for operating this. And with this, you also get the clear, yeah, defined responsibility. Who is responsible for what? Because the simple object, what is for your developer, it's in the responsibility of the developer. But how the implementation looks in the back end, it doesn't matter. Same as on the hyperscalers. We have the API. How they do it in the background, we don't care really. I mean, from as an IT person, sometimes you care because it's just interesting how they're doing it. But at the end, you want to have a database. If there's someone clicking it together manually, or if they end-to-end automating this, if they run this on VMs or containers, you don't care. You want to have the database, you want to have the endpoint, you want to have the password and so on. That's mostly what you care, and then the availability. The rest, you don't care. And I think this is exactly, or that's the parameter or the concept we are following, and we are pushing. Like, hey, you have this expert teams in bigger organizations. It's unrealistically that you have a database expert in each development team, same as you don't have an Kubernetes expert in each team. So we need to find abstractions and higher level ways how we can make it more simpler for the people. But on the other side, that the teams who are really responsible on operating this can manage and run this at scale.
Do you think we're at some point going to be converging with this sort of managed Kubernetes, converging with serverless computing platforms? Um, or, yeah, I mean, how far are we from that kind of convergence? Where are we on this journey of, abstracting away infrastructure?
I think the question is how far does an application needs it. I think it really depends really on the application and what the developer needs. I think in a lot of cases, still containers are a good way, but like how detailed the developer needs to see stuff, that's TBD. And I think there we can build some abstraction layer. And also, like what I said before with the AI use case, I think here it can really help to abstract some stuff away from the developer, so that at least in the day-to-day business, he don't needs to look into it. But the good thing is, as you have all the resources and you have a standardized API, if you say, hey, I need to go one level deeper, you can every time do it. I think in the past, we every time had the problem with serverless tools and so on. If your application works on the serverless tool, it's good, but potentially you start small as an MVP, and then your application grows and it grows. And at a certain time, you're realizing, oh, now I have more requirements to this, which every time where potentially the serverless architecture is not a fit anymore and cannot fulfill this, and you want to go to a new architecture, then you every time had to be a big re-architecturing, which was quite cost intensive, and also create a lot of new learnings for the developers. And here I think it's a big value of Kubernetes, because it's a common API layer. You can build this higher level abstraction, But if the developer then says, hey, I now need to go deeper, he don't needs to learn a complete new tool chain, development way, and so on. Of course, he needs to get more deeper into, for example, networking and so on. But a lot of stuff is common to him, so the learning curve don't needs to be so high, and also the migration effort is quite seamlessly. Potentially you have a bit of, but it's not like, oh yeah, I now need to migrate from system A to system B and more or less rewrite a lot of stuff.
All right, interesting. I was wondering if you could show us a demo of what Kubermatic looks like and some of the key capabilities.
Yeah, absolutely. Let me.
Yep, see it.
So yeah, what you're seeing here is our product, Kubernetic Kubernetes platform. So here the idea is really about managing the life cycle of Kubernetes cluster. I mean, we talked about a bit of the developer platform. It goes quite similar. It's a bit of different product because it's more flexible. But yeah, let's look into the container management in general. And as I said, like our idea was from the first day on, we want to help our customers to make it as self-service as possible. So what you see here is our UI. Typically, it's deployed inside of the accounts of our customer. So it's not a SaaS offering. It's running inside of the accounts in the cloud accounts or on-prem or the edge of the customer. And what they can do, the first thing is like before a developer can start, they need to create a project. And the project is more or less a separation, how you separate different teams, different organizations from each other. So you have directly built in like multi-tenancy capability, and a user from one project, depending on, cannot see all the project or cannot access the other project. So he first need to give us the permission to get into this. Yeah, and then, I mean, giving a quick overview, the first thing what you can do is like creating a cluster. So you can either create cluster which are managed and where the control plane is also managed by us, or you can create clusters where yeah, we're managing EKS, AKS, or GKE cluster. When we create a cluster, so the platform team in the back who is operating the platform can decide which provider I want to support. So we're supporting the major hyperscalers, but also then yeah, on-prem, different VMware flavors, Nutanix, OpenStack, but also bare metal provisioning and KubeVirt, so that you can run a bare metal Kubernetes cluster and leveraging the KubeVirt VMs for your application cluster. And yeah, then you can define, depending on the provider, what data centers you want to allow. Gives a cluster name, can choose the version, enable or disable specific features, what the cluster has. So for example, if you want to do policy management, enable either OPA or Kyverno as a policy engine. The developer team then can either provide their credentials, or the platform team can define also, we call it presets, credentials, which are provided by them so that the developer don't even need access to the provider, for example, in this case, to the AWS. You can choose how many nodes, what type of nodes we support, Intel, AMD, and as well ARM architecture. And also the major operating systems. You can define the size. Then it depends every time a bit of what the provider is providing. So if they're providing Spot, for example, on AWS, we're providing access to Spot instances so that we deploy Spot instances. We can enable auto scaling and so on. And yeah, you can directly now or later deploy application on top of the cluster. And now we would create a cluster. I have already a cluster running. So you can go to the cluster, and here you can do, the developer can do the whole lifecycle management. Like they can decide when to upgrade a cluster, when to, if something, the good thing is if something here fails, so for example, if a node fails, everything is reconciling because we're leveraging completely Kubernetes. So everything what you see here is managed based on CRD on a Kubernetes cluster. So if a node would fail, it would automatically restart it. And yeah, you can use a web terminal to access it. You can download the kubeconfig, install additional applications, and so on and so on. I mean, the main idea here is really we want to help our customer to manage tens or hundreds or thousands of clusters. So you see this, I mean, if you compare this to the hyperscalers and so on, it looks quite similar, but what we give you is like the flexibility that we help you to manage this across all the providers. So we can give you the umbrella across all the different providers and can help you to manage all your Kubernetes cluster in your organization, with then also things like cluster backup and restore, so that each development team can define a backup location and can define when do they want to schedule backups, or if they have backups, they can restore. That either the platform team can define, but also each developer team or project team can define policies. So for example, you can make policy, you see a scope, if it's global for all the Kubernetes clusters, if it's based only for a specific project, is it based only for a specific provider or individual cluster, you can then define if this is default deployed to the cluster. For example, what you can ensure is like, hey, I only want to allow services exposing the services encrypted. So over HTTPS, I'm blocking unencrypted services. And then you just define here a policy, and it would be rolled out to all your clusters. And you can define if you want to just get a warning, or if you really enforce this and block this and so on. And so we every time have the scale idea in mind, like how can we help our platform teams to manage this at scale across all their hundreds or thousands or 10,000s of clusters in a scalable and easy way. And especially also the idea of like, how can we help the platform team and also the development team to make the cluster lifecycle? So say, hey, now each development team could choose like, oh yeah, I want to upgrade to another version, so they can upgrade to it, or the platform team can force upgrading clusters when they say, hey, we this version is end of life, now I'm upgrading, informing the developers and upgrading all the clusters I'm having. Yeah, that's in a quick nutshell what our Kubernetes Kubernetes platform is doing. Having a lot of more capabilities, but yeah, just
Mhm.
quick
Yeah,
overview.
yeah, yeah. It's quite a a lot of features that you would mention there. And I was wanting to know, so if I want to move a cluster across uh, different another vendor, is that possible at all, or would it need to be recreated? You can't just migrate it from, let's say, AWS to GCP.
Um, I mean, it depends a bit. What we have is on the one side with this application backup, so we can do a backup of the existing cluster and restore into a new cluster. Um, that's definitely one way how to do this. The good thing is what you also can do is like, if you have already existing clusters running, you can connect any kind of cluster to our platform, or import GKE or the hyperscaler clusters, where we then do also the lifecycle management, so that you first of all get the umbrella. That's what we really can do, and where we help our customers with.
Mm-hmm. Yeah, we're winding down. Last couple of questions. You mentioned about scale, that Kubernetes is built to run clusters at scale. Where do you think Kubernetes use case really shines through when your customers operate at scale? Which are the biggest, most thorniest challenges that Kubernetes helps to solve?
I mean, yeah, one of the biggest challenges where we help our customers and where we can really shine is like when customers need to manage a lot of Kubernetes clusters. Like we had from the first day on the idea, it should not matter if you run a lot of a few big clusters or a lot of small clusters. In best case, you even run a lot of small clusters because then each team can better individually decide when to upgrade. When you really want to have this one umbrella which helps you to manage all of your Kubernetes cluster in your organization, that's where we really shine. And also, I mean, our platform is open source. We're relying completely on upstream open source. We are really active on Kubernetes as well. So if you really want to fulfill an open source philosophy, I think we are definitely a good company to go to because open source is exactly what we're living, what we're doing day to day, and helping our customers with this. And really, when you have this platform idea in mind, so you have dedicated teams who should run all of your Kubernetes cluster, or with developer platform who should build a developer platform to manage this and operate this.
All right. So yeah, with that, we come to the end of our discussion on all things Kubernetes and Kubermatic as well. Before you go, Sebastian, just I want to get to know you a bit with just one question that I ask all of our guests, which is, what would be your alternate career path if not for your career in tech?
Yeah, I mean, that's a really tough question. I never asked myself. I was every time when I was young fascinated about IT. I think the closest one is I think I would go into some engineering because that's also technology is interesting for me. If it's IT or not, I like technology. So I think engineering could be something else where I definitely would be fascinated and have the drive to really push this day by day.
All right, cool. Yeah, I guess you're right where you want to be.
Absolutely.
Great. Thanks so much for joining us, Sebastian. It was a pleasure chatting with you, especially about just remembering the old times of when Kubernetes just began. That was a really nice part of our conversation, and really interesting to also get to know your approach with Kubernetes and how you approach platforms itself. Building platforms on the base platform of the Kubernetes API itself. Really interesting take there. And great demo as well, showing us how you support clusters that run on any hyperscaler and even some of the smaller cloud platforms. Lots of support and your open source philosophy. So quite a in-depth and detailed conversation. It was a pleasure chatting with you. Thanks so much for joining us.
Yeah, thanks for inviting me. It was really a pleasure talking with you.
All right. And thanks to all of our listeners and viewers for tuning in. We hope you enjoyed this conversation, and we hope you'll join us for the next one. Stay subscribed, and we'll see you on the next episode. Bye bye.